Welcome back to the Professor Insight podcast, your space to explore the intersection of artificial intelligence, neuroscience, and emerging technologies, and turn it into something practical for your work, your strategy, and your thinking. I'm Professor Billy, your host. At the start of this episode, we would like to acknowledge that this podcast is fully powered by AI tools, from content creation and script writing to voice generation. In fact, this voice you are hearing now is a voice clone of myself. This is all done with human supervision and manual curation. Now, today's episode is one I've been looking forward to sharing. If you've been following this podcast, you know we've covered large language models and agentic AI. But today, we're getting hands-on. We're talking about building agents, not just talking about AI agents, but doing something with it. This episode is based on OpenAI's recent publication, A Practical Guide to Building Agents. And to be clear, this guide is not theoretical. It's written for product and engineering teams looking to build their first LLM-powered agents. It distills lessons from real-world customer deployments into practical frameworks and actionable insights. And while the guide is technical in nature, this episode on Professor Insight podcast is all about translating that into what it means for business teams, strategic leaders, and decision makers. We're going to break down the essentials. What is an agent and how is it different from a traditional chatbot or rule-based automation? If you would like a deep dive on this or refresh your mind, go back to episode 5 and 6 where we talk about AI agents. In this episode, we will also go through when should a business consider building an agent? And when is a simpler solution enough? How do you design an agent that is safe, scalable, and actually useful? What kind of workflows are best suited for agents, and which ones still require human oversight? Agents represent the next evolution of intelligent systems. They don't just respond to prompts. They make decisions, take actions across tools, and adapt dynamically to reach goals. In business terms, that means unlocking automation for processes that were previously too complex or context-driven to handle with traditional software. We'll walk through how to think about workflows that benefit most from agents. These include complex decisions that can't be reduced to checklists, iterations involving a lot of unstructured data, like documents, conversations, or customer reviews, high-friction tasks like refund approvals, vendor reviews, or support ticket routing. We'll also look at the foundation of good agent design, models, tools, and clear instructions, as well as orchestration strategies like single agent versus multi-agent systems. We'll even talk about guardrails, what it takes to make agents safe, reliable, and aligned with company values and data security requirements. And finally, we'll explore one of the most important pieces that often gets overlooked, human-in-the-loop design. Because no matter how smart your agent is, having the ability to escalate to a human when something's unclear or high risk is not just a best practice, it's essential. So let's dive in with our AI discussion duo.
So you're probably listening because you're looking for, smarter ways to run your business operations, maybe wrestling with tricky data or just trying to smooth out those operational bumps. And you've likely heard about automation.
A lot of buzz there.
Exactly. But today, we want to go beyond the usual chatbots, the simple rule-based stuff. We're going to dive deep into agents.
Yeah, these agents, they're kind of the next step, powered by large language models, and they can genuinely operate on their own.
Okay, so the plan today is really to get into when building an agent actually makes sense for a business, what you'd really need to build a good one, and the basic process involved.
Precisely. We're not talking about just a language model answering a question here. This is about systems that can manage a whole task, a workflow, from beginning to end pretty independently. We've gone through the key info to really pull out what matters most.
All right, let's start there then. What exactly is an agent in this context? It feels like a word that could mean, well, a lot of things.
That's a fair point. At its core, based on what we've looked at, an agent is a system designed to independently accomplish tasks for you. Think of it like a digital assistant handling a sequence of actions, a workflow to reach a goal without needing you to step in constantly. Could be resolving a customer issue, generating a complex report, things like that.
And how is that different from just plugging in an LLM somewhere?
The key difference is that the agent uses the LLM not just for, say, one response, but to actively steer the entire workflow. It makes decisions along the way, can change direction if needed.
Oh, okay.
And importantly, it can access external tools to gather information or take action in other systems. It's not just thinking, it's doing.
It's actually doing things.
Yeah.
That makes a lot more sense. So the big question then, when should a business even consider building one? Sounds like it's definitely more involved than a basic LLM integration.
It absolutely is. And that's really the crux of it. Building agents isn't just a tech upgrade. It's a shift in how your systems handle complexity. Traditional automation loves fixed rules, right?
Yeah, checklists, step-by-step procedures.
Exactly. Agents really come into their own where those rigid approaches start to struggle. Let's take payment fraud analysis as an example.
Okay.
A traditional system might have that checklist of red flags. If X, Y, and Z, then flag as fraud.
Standard stuff.
But an LLM agent, it can act more like, well, like a seasoned human investigator. It can look at the whole picture, the context, spot subtle patterns that aren't on any checklist, and make a judgment call, even in those murky gray areas.
So it handles the ambiguity better, it depends situations.
Precisely. That's where they really shine. They excel where that human-like judgment is needed. So that ability to handle nuance is a major advantage.
Okay, I see the value there. So based on our sources, are there specific types of workflows where this approach really makes the most sense?
Yeah, the guide we've been digging into really flags 3 main areas where agents can add significant value. First up is complex decision-making.
Right.
These are workflows with lots of nuanced judgment calls, exceptions popping up all the time, or decisions that really depend on the specific context.
Like approving a customer refund, maybe.
That's a perfect example. It's rarely just a simple yes or no, is it? An agent can look at the customer's history, the reason they're asking, other factors, and make a much more informed decision than a rigid rule saying refund if under $50 or something.
Because those rigid rules always end up with tons of exceptions anyway.
Exactly. The traditional systems get bogged down in those it depends cases. So for nuanced problems needing judgment, agents are a strong contender.
Makes sense. What's the second area?
The second one is dealing with difficult-to-maintain rules. We've all seen these systems, haven't we?
Oh, yeah. They start simple.
And then they just grow. Layer upon layer of intricate rules trying to cover every single possibility. Updating them becomes a total nightmare. It's costly, time-consuming.
And you always break something else when you change one rule.
Right. Vendor security reviews were mentioned as a good example. The criteria you need to check, the data sources, they can change quite often. A rules-based system becomes a constant maintenance headache.
I can picture that sprawling checklist getting longer and longer.
Whereas an agent, using its language understanding, can adapt more fluidly to those changing requirements without needing a complete rules overhaul each time. For systems just drowning in rules, agents can be a real lifeline.
Okay, complex decisions, painful rules, maintenance. What's the third one?
The third key area is when there's a heavy reliance on unstructured data.
So like text, documents, conversations.
Exactly. Situations where you're dealing with natural language, extracting meaning from, say, long documents, or managing conversational interactions. Think about processing a home insurance claim.
Yeah, lots of different documents there. Claim forms, maybe police reports, customer emails.
Tons of unstructured stuff. Traditional systems are often pretty bad at understanding and pulling out the key info from all that text. Agents, though, with their NLP capabilities, are much, much better suited for those kinds of tasks. When you're buried in documents or conversations, agents can really help dig you out.
So let me just recap. Complex decisions, rules that are a nightmare to maintain, and workflows heavy on unstructured data like text. Those are the prime candidates.
That's the core idea.
But what if my workflow is actually pretty straightforward? Clear rules, structured data, not too many exceptions.
Then you probably don't need to jump straight to building an agent. That's a really crucial point the guide makes.
Right.
Before you invest the time and resources, you absolutely need to validate that your use case clearly fits one or more of those categories we just discussed.
Otherwise,
you might be over-engineering it. A simply, more deterministic automation solution might be perfectly adequate and probably more efficient and cheaper to build and run. It's about picking the right tool for the specific job, you know?
Right tool for the job.
Got it. Okay, so let's say we've identified a good use case. It ticks those boxes. What does a business actually need to have, sort of the ingredients, to build a good agent?
Okay, moving on to the what. According to the guide, There are really three fundamental building blocks. You need the model, that's the LLM, the brain doing the reasoning.
The engine.
The engine, yeah. Second, you need tools. These are the agent's hands and eyes, basically external functions, APIs that let it interact with other systems. Get info, take action.
Okay, model, tools.
And third, you need clear instructions. These are the rules of engagement, the guidelines, the guardrails that tell the agent how to behave and operate.
All right, let's unpack those. The model first, the LLM. How do you pick the right one? Is it just like grab the biggest, most powerful one off the shelf?
And not necessarily, no. It's more nuanced. Different models have different strengths. Some are amazing at really complex reasoning. Others might be faster or cheaper for simpler tasks.
The recommendation is generally to start prototyping with a pretty capable model, like maybe a GPT-4 or something similar, to see what's possible, to set a performance benchmark.
Get a baseline.
Exactly. Once you've got something working, then you can experiment. Try smaller, maybe faster or more cost-effective models, see if they can handle the job or maybe parts of the job well enough.
So you might mix and match models.
You might, especially in more complex setups. You could use a powerful model for the core reasoning and maybe a faster, cheaper one for simpler subtasks. The key is rigorous testing and evaluation at each step.
Makes sense. Start strong, then optimize.
Yeah.
Okay, what about these tools? You said they're like the agent's hands and eyes. What kind of things are we talking about?
Tools are really how the agent connects to everything else. The guide groups them into roughly 3 types. First, data tools.
For getting information.
Right. Querying databases, reading files, searching the web, pulling up customer records, anything that gives the agent context. Second, action tools. These let the agent actually do things in other systems. Sending an email, updating a CRM record, creating a support ticket, maybe even handing off a task to a human.
Taking action based on the data and its decisions.
Exactly. And the third category mentioned is orchestration. This is interesting. It's where agents themselves can act as tools for other agents. We can circle back to that when we talk about multi-agent systems.
Okay, agents calling other agents. Got it.
Yeah.
So the agent isn't just stuck in its own little box. It can fetch data and then actually make changes in our real systems. That sounds incredibly powerful.
It is. That's a big part of what makes them agents rather than just chatbots.
So what makes a good tool then? Can I just point it at any old API?
Well, you could try. But for reliability, there are some best practices. Each tool really needs a clear, standardized definition so the agent and potentially other agents knows exactly what it does and how to use it.
Like a clear label and instructions.
Exactly. Good documentation is crucial. How do you call it? What parameters does it need? What does it return? Also, thorough testing is non-negotiable. You need to trust that the tool works reliably.
Right. Don't want the agent sending 1,000 incorrect emails.
Definitely not. And ideally, you want tools to be reusable across different agent workflows. Build it once, use it many times. That saves effort and makes maintenance way easier.
And what about older systems? Things that don't have nice, clean APIs? Are they just out of luck?
Not necessarily. The guide mentions something pretty cool called computer use models. These are basically AI systems that can learn to interact with software just by watching the screen like a human does.
So it can click buttons and fill forms in an old application.
Yeah, essentially. It learns to navigate the user interface. It's a way to bridge the gap and automate interactions even with legacy systems that weren't designed for API access. Pretty clever.
That is clever. Okay, so model tools. The third piece was instructions. This sounds like where we define the agent's actual job and its boundaries.
Absolutely critical. High-quality instructions are maybe the most important factor in getting reliable performance. They cut down on ambiguity, they improve the agent's decision-making. It all leads to smoother workflows and fewer mistakes.
So how do you write good instructions? Is it like writing code?
Not quite code, but it requires clear thinking. The guide suggests several good practices. One is don't reinvent the wheel, leverage your existing documents.
Like SOPs or support scripts.
Exactly. Standard operating procedures, policy documents, call center scripts, these often contain the logic you want the agent to follow. Use them as a starting point.
Smart.
Another key thing is prompting the agent to break down big tasks into smaller, manageable steps. And for each step, define very clearly what action the agent should take or what output it should produce.
Be explicit.
Be very explicit, even down to the wording of messages it might send to users. The less room for interpretation, the better. And crucially, think about edge cases.
What happens when things go wrong or the user asks something weird?
Right. What if the data is missing? What if the user gives conflicting information? Good instructions need to anticipate these and provide guidance, maybe conditional steps, Or rules for when to ask for clarification or when to hand off to a human. It's like writing a really, really detailed flowchart or playbook, but for an AI.
A very detailed playbook makes sense. And I think you mentioned earlier, sometimes you can even use other LLMs to help generate these instructions.
Yeah, the guide points out that advanced models can sometimes analyze your existing documents and generate a first draft of the agent instructions, which could be a huge time saver. You'd still need to review and refine it, of course.
Of course. Okay, so we've got the core components, the model as the engine, tools for interaction, and instructions as the playbook. How do these all work together in practice? What's the actual process or structure for building and running an agent?
Right. That brings us nicely to orchestration. This is all about how you structure the agent's operation, how you manage the flow to get the workflow done effectively. And the key advice here is to start simple. Begin with a single agent for your task. Only scale up to more complex multi-agent systems if you really need to.
Keep it simple first. I like that.
Yeah.
So how does that single agent actually work? Does it just run once?
Typically, a single agent operates in a loop. It gets some input, uses its brain, the LLM, and its instructions to figure out the next step. Maybe that step involves using a tool.
Like fetching some data.
Exactly. So it calls the tool, gets a result back. Then the LLM looks at that result, considers its instructions again, and decides the next action. Maybe use another tool, maybe generate a response to the user, maybe finish the task.
And it keeps going around that loop.
It keeps going in what's called a run until it hits some kind of exit condition.
Where the be?
Could be several things. Maybe the agent calls a specific tool that means job done. Or the model decides it just needs to send a final message back, no more tools needed. Or maybe it hits an error it can't resolve. Or you might set a limit, like a maximum number of turns or steps to prevent infinite loops.
A safety net.
Right. The guide also mentions using prompt templates within these single agents. It's a way to structure the prompts you send to the LLM, making it easier to handle variations in tasks or inputs without writing totally separate instructions for every little thing. Helps manage the complexity.
Okay, so a single agent looping through steps, using tools, guided by instructions and templates, seems like it could handle quite a lot. When would that not be enough? When do you need multiple agents?
Good question. The guide suggests a few indicators. One is if the core logic gets really complex. If your instructions start looking like a giant maze of if this, then that, unless this other thing.
Yeah, super convoluted.
Right. If the prompt templates become incredibly unwieldy, that might be a sign. Another big one is what they call tool overload.
Too many tools.
Not just the raw number, although that can be part of it. It's more if the tools are maybe too similar or overlap a lot in what they do. If you find that even with really clear names and descriptions, the agent keeps picking the wrong tool for the job.
It gets confused.
Yeah, it gets confused. Splitting the tasks and assigning specific, distinct sets of tools to different specialized agents might actually improve accuracy and reliability.
Okay, so if it gets too complicated or the agent gets confused by its tools, maybe it's time to bring in reinforcements. What do these multi-agent systems look like?
The guide mainly talks about two common patterns for coordinating multiple agents. The first one is the manager pattern.
A manager, like a boss agent.
Kind of, yeah. Think of a project manager agent who assigns specific tasks to different team members who are also agents. So you have this central manager agent that orchestrates a team of specialized agents.
How does it assign tasks?
It usually calls the specialized agents just like it would call any other tool. The manager keeps control of the overall workflow and presents a single, unified interface back to the user or the system.
Can you give an example?
Sure. Imagine a main translation agent. If a request comes in for Spanish, it calls its specialized Spanish translation agent tool. If it's French, it calls the French agent tool. The manager figures out which specialist to use and handles passing the information back and forth.
Okay, so the manager is the conductor directing the specialist agents. Makes sense. What's the other pattern?
The other main one is the decentralized pattern. This is less like a hierarchy and more like a team of peers.
No single boss.
Right. Imagine a team where anyone can hand off a task directly to the colleague who's best equipped to handle the next step. Agents operate more as equals.
How does that work?
They essentially hand off control of the workflow to each other based on their specialization. A classic example is in customer service. You might have a triage agent that first talks to the customer.
Figures out what they need.
Exactly. Then, based on the issue, it might hand the whole conversation off directly to a sales agent or a technical support agent or maybe an order management agent. Control passes from one specialist to the next.
So manager pattern is central control. Decentralized is peer-to-peer handoffs.
That's a good way to put it. The guide also briefly touches on how you define these workflows. Sometimes it's declarative, like drawing a graph of the flow. Other times it's more code first, like using specific libraries or SDKs designed for building agents.
Okay, different ways to build a structure. Now, whether it's one agent or many, things can still go wrong, right? We need safety nets. You mentioned instructions act as guardrails, but are there other kinds?
Absolutely. Formal guardrails are super important.
Yeah.
This is all about managing risks, data privacy, stopping the agent from doing harmful things, protecting your company's reputation, preventing costly errors.
Makes sense. It's got access to tools. It could potentially do damage.
It could. So the guide stresses using a layered defense, not just relying on one single check, but using multiple specialized guardrails working together.
Okay, like what kind of layers?
Several types are mentioned. You might have a relevance classifier at the input, checking if the user's request is actually related to what the agent is supposed to do.
Stop it going off topic.
Right. Then maybe a safety classifier looking for malicious inputs, like someone trying to trick the agent, prompt injections, jailbreaks, that kind of thing.
Security checks.
Definitely. A PII filter is crucial, scanning both inputs and potential outputs to make sure sensitive personal information isn't accidentally revealed.
Protecting privacy.
You can also have moderation filters, checking for harmful or inappropriate language. Then there are tool safeguards. This involves thinking about how risky each tool is.
Like sending an email is low risk, but deleting a database record is high risk.
Exactly. So for high-risk tools, you might build in extra checks or confirmations before the agent is allowed to execute them. You can also use simpler rules-based protections, like blocking known bad words or limiting input length. And finally, output validation, checking the agent's final response to make sure it sounds right, aligns with your brand voice, doesn't contain anything weird.
Wow, okay, that's quite a few potential layers. It seems like you could spend forever building guardrails. How do you decide which ones you actually need?
Yeah, you don't necessarily need all of them for every agent. The guide offers a practical approach, a heuristic. Start with the basics. Focus on data privacy, like PII filtering, and basic content safety first.
Cover the big risks.
Right. Then, as you test your agent, as you see where it fails or encounters weird situations in the real world, add more specific guardrails to address those actual problems you're seeing.
Learn from experience.
Exactly, and keep refining them. Optimize for both security and the user experience. You don't want the guardrails to be so strict that the agent can barely do its job. It's a balancing act.
An iterative process, like the rest of agent building.
It really is.
Okay, so we've got orchestration, we've got guardrails. What happens if, despite all that, the agent just gets stuck? Or maybe it's about to do something really important and we're not quite sure we trust it yet.
That's where human intervention comes in. It's a critical piece of the safety puzzle. You need a plan for bringing a person back into the loop when necessary.
So it's not always fully autonomous.
It doesn't have to be, especially at first, or for certain critical tasks. The guide points to two main triggers for bringing a human in. One is simply exceeding failure thresholds.
Like if it tries 3 times to use a tool and fails each time.
Exactly. If it keeps hitting a wall, that's a good signal that it's stuck and needs help. Don't let it just keep spinning its wheels or making things worse. Time to escalate to a human.
Makes sense. What's the other trigger?
The other main one is for high-risk actions. Even if the agent thinks it knows what to do, for certain actions, maybe canceling a large subscription, authorizing a big refund, changing critical account settings, you might decide that requires human approval.
An extra layer of oversight for the really sensitive stuff.
Precisely. Especially when you're first deploying an agent, building in these human review steps for high-stakes actions gives you confidence and reduces risk while you're still learning how reliably it performs. Having a smooth way for the agent to say, I need help, or please approve this and hand over control to a person is key for both safety and a good user experience.
So it's really about augmenting human capabilities, automating what makes sense, but keeping that human safety net readily available.
That sums it up perfectly. Agents are undeniably a powerful evolution, especially for tackling those complex, ambiguous, data-heavy workflows that traditional automation just couldn't handle well.
Yeah.
But building them well requires that thoughtful approach we've been discussing carefully, considering the model, the tools, the instructions.
Choosing the right orchestration pattern, building robust, layered guardrails.
And always having that human intervention option in your back pocket.
It really sounds like the journey is iterative. You don't build the perfect, all-singing, all-dancing agent on day one.
Absolutely not. Start small. Pick a well-defined use case where it offers clear value. Build it, test it, validate it with real-world use, and then grow its capabilities based on what you learn. That's the path to success.
It's about intelligent automation, adaptable automation, tackling whole workflows, not just isolated clicks.
Exactly. And done right, they can unlock significant business value.
So maybe a final thought for everyone listening. Think about your own business. Is there a workflow, maybe one that's always resisted automation attempts, or one that's just bogged down in complexity or unstructured information? How might these ideas, models, tools, instructions, orchestration, guardrails, offer a new angle, a new path forward for tackling that challenge? It might be worth exploring some of the further resources mentioned in the guide, things like the API platform details, OpenAI for business info.
Yeah, definitely worth digging deeper if this resonates. It's a space that's moving incredibly fast, and understanding these fundamental concepts is really the first step to harnessing the potential for your own organization.